Hello, ladies and gentlemen. I hope you are enjoying your learning with us at Transcar Consulting Services. I am your number one Acca tutor, Mr. Jeremy Timukulu. And as I have always promised my legion of fans and my students, if you do not become a formal student, yes, you're going to benefit from watching the video, but you are missing something. All right. For you to pass a professional examination, you need a constant tutor, a dedicated one, somebody who is going to offer you continuous assessments as well as 24-hour, 7 days a week, 365 days a year, continuous support throughout your studies. Okay, so we are there to just ensure that there is no point, or there is no a particular moment you are going to stuck at any part of your journey. You're not going to stuck at any point. Okay, we are always going to be there to support you, to give you the necessary feedback you need, and to actually coach you to become a better accountant. All right, so please consider that, or consider referring your friends to us. All right, now in the previous video we covered the aspects of capital rationing. Here we are going to look at this noble area of asset replacement, because by the end of the day a company should have an optimum asset replacement policy. All right, if you still remember, we have been so far talking about investing in machinery, investing in buildings. I mean, we are centered on just purchasing a capital asset. But these assets are not going to be there forever. There shall come a time where they need to be replaced. So you need to ask yourself, at what point shall I replace? What is going to trigger me to replace an asset, and how often must I replace that asset? Obviously, the reason why you're going to, or that is going to uh, cause you to replace an asset, is that the former asset could be uh, behaving in an inappropriate manner. Okay, or it might be turning to be ineffective, or it has broken down, it has got some endless breakdown. All right, so in that case you need to replace that asset. All right, there are also costs that you need to bear. For example, cost of maintenance. The older the assets, the more expensive it becomes in terms of maintenance. So you need to put that into consideration. Also, if you keep on holding to an asset, for example a car, because you are loyal to the brand, or to it in general, that you can't actually divorce away from it, then there is a risk that when you decide to sell it, you're going to fetch very little in terms of scrap value. Okay, so the sooner you dispose of it, the better, because you're going to get more money. You dispose of it early, you're going to get some more money. However, there is also a downside you need to consider, because if you dispose of the asset so early, it means, yes, you're going to get more money, but at the same time you are also going to be forced to buy a new one, which might also turn out to be expensive for you. All right, so as a financial manager, you need then to consider what is called the equivalent annual cost. The equivalent annual cost. When you are clinging to an asset, or when you are having an asset, or when you decide to dispose of it, what is the equivalent annual cost, right? Equivalent, let me try to write it somewhere here. Okay, the equivalent. All right, annual cost. Okay, it is usually shortened EAC. All right, and this is okay the annual cost of owning, operating, and maintaining an asset over its entire life. Okay, so we need to determine this cost so that we come up with a good asset replacement policy. All right, so you see with this coming example how by the end of the day a finance manager or a financial manager is going to inform the board of directors or his company's management on the best way to handle their non-current assets. All right, so let us get a look at this one. A machine costs $72,000 and there's a maximum life of 3 years. The running cost of the running costs each year are as follows. So these are the running costs: year 1 7,200, year 2 9,600, year 3 12,000. And then the estimated scrap values are as follows: 12,000 in year 1. So which means if we decide to dispose of the asset in year 1, we are going to fetch $12,000. Okay, so if we decide to dispose of the machine, all right, in year 2, then we are going to fetch 16,600, and in year 3 9,600. So you can see the older the machine, the lower the scrap value. That's what usually happens in the industry. Okay, because the longer the lifespan, the longer the years the machine is put into use, the lower the value it becomes or it fetches as it grows. All right, so now how often should the machine be replaced? We are going to use the principle of EAC, the equivalent annual cost. Okay, because this principle enables us to compare assets of similar lifespan. Okay, enables us to compare the costing nature. Okay, how costly it becomes to have an asset or to maintain or to keep the asset. All right, so if we decide to dispose of it, which one is going to be the best possible route to follow? Shall we replace this asset over 1 year, or shall we replace it over 3 years or over 2 years? That depends on the results of the assessment, the equivalent annual cost assessment. So let's start with the replacement cycle of 1 year and see what we can get. Okay, so 1 year replacement cycle. All right, 1 year replacement cycle. So if we follow the 1 year replacement cycle, we are going to have year 0, year 1, the cash flows. Okay, the cash flows involved in year 0. This is when we buy the machine. That's 72,000, and our discount factor at 15%. We're given the rate is 15%. The cost of capital is 15%. So in year 0, obviously it's 1. Then our PV here is going to be negative 72,000 multiplied by 1 comes to 72,000 negative. All right, and then in year 1, okay, we are going to incur operational or operating costs or running costs of 7,200. So these ones are negative again, 7,200. Okay, and then we are also going to have a discount factor. All right, the discount factor 1 over 1.15 to the power 1. Remember, this is year 1, so it's to the power 1. And we are going to get how much? Let me use my calculator here. All right, that's 0.870. 0.870. So if we multiply 0.870 by negative 7,200, we must get how much? That's 6,264. Okay. Now, in the same year again, we are going to fetch this 24,000 as our scrap value. If we replace, we dispose of the machine and get 24,000. All right. All right. So this is also going to be discounted using the same rate for that year, since it is going to be done in year 1. So obviously 24,000 multiplied by 0.870, we're going to get 20,880. So let's add up and get our net present value. NPV is also going to be, remember this is negative. All right. So we're going to have 57,384. This is negative. All right. But remember, don't be confused. Don't be confused here. This, we just want the minimum cost. All these are costs. All right. The only revenue we are going to get is the scrap value when we dispose of the machine. All right. So the idea here is not about whether the negative NPV or this is that. All right. We are simply comparing the cost. Okay. So the NPV here is the net present value of the cost. Net present value of the cost. So that machine or that replacement cycle, that is going to give us the minimum cost. That's what we want. All right. So now here we determine the NPV. Now let us then determine the equivalent annual cost. So equivalent annual costs, EAC, is going to be the NPV, all right, and the annuity factor. The annuity factor, all right. This, in this particular example, the annuity factor applicable is for 1 year at 10%. Remember at 15% rather. Okay, annuity factor 1 year at 15%. So annuity factor 1 year at 15%. All right, and this is going to be, the NPV is negative 57,384 divided by the annuity factor 1 year at 15%. That's the same as the discount factor there at 0. Okay, and we must get a figure that is how much? 65,959 per annum. That's per year, per annum. So the equivalent annual cost tells us that each year we are going to incur a cost of 65,959 if we replace the asset. We replace the asset every year. Our cost is going to be 65,959. Our annual cost. All right. What about if we dispose the asset over 2 years? Okay, so let's see what the two-year replacement cycle brings. So once again, we have got our year 0, 1, 2, and 2, because there is a running cost in year 2 and there's also a replacement value, I mean the scrap value in year 2. Then we've got our cash flow. The initial investment is just 72,000. Remember, I said the equivalent annual cost is usually used to convey assets of the same maturity, of similar characteristics. Okay, so the cost of the asset is just $72,000, right? And the discount factor is at 15% as usual. So in year 1, that's in year 0, that's 1, and then we've got the PV column. The PV becomes 72,000 negative. All right, and then we have got the running cost as usual of 7,200 in year 1, and we are also going to use the same discount rate, discount factor in year 1, and if we multiply these ones, we found what we found. That's 72,000 multiplied by 0.870. That's 6,220 and 64 negative. All right, and then in year 2, the running cost becomes how much? 9,600. 9,600. These are the running costs, and the discount factor for year 2 now 1 over 1.15 to the power 2. And what do we get? That's 0.756. So if you multiply there, we get negative 7,258. All right, and our scrap value, when we dispose of this asset, and we fetch scrap value of 16,600. This is a positive figure. All right, and we are going to discount it with the same year 2 discount factor, and we get our 12,550 positive. Let us add these figures up, ladies and gentlemen, and we get our NPV. And this one is 72,972. All right, so the EAC applicable in this case should be the NPV, that is 72922. Okay, over the annuity factor 2 years. Annuity factor 2 years at 15%, and this should be 1.626. Please visit your annuity tables and verify. Okay, you can verify with your annuity tables. We do not have time to dilly-dally. All right, so here we get the annual equivalent cost of 44,878 per annum. So each year, if we replace the asset over 2 years, every year we are going to incur 44,878 per annum. That's what it means in financial management terms. Now let's look at the cycle, the 3-year replacement cycle, and see if we can make sense out of it. So 3-year replacement cycle. As usual, year 0, 1, 2, 3, and 3. Okay, and then we have got the cash flows. The cash flows are made up of the negative 72,000, which is the initial investment, and then running costs 7,200 and 9,600, and then 12,000 running costs. And then we've got a scrap value of 9,600 in year 3. Then our discount factor at 15%. Year 1 is, year 0 is 1, and then 0.870, and we discovered how much here, 0.756. And then in year 3, we said 1 over 1.15 to the power 3. So we get how much there? 0.658. Okay, 0.658, and we are going to use the same figure here. Then our PV, the PV is obviously in year 0, we are going to get 72,000. Then here we have got, as usual, 6264, and then 7258. Then here we get 7896, and then 6317 positive. We add them up, we get an NPV of how much? That's negative 87,101. Obviously, the EAC will be 87101 divided by the annuity factor at 15% 3 years. Annuity factor at 15% 3 years, that's 2.283. This gives an equivalent annual cost of 38,152 per annum. Okay, so ladies and gentlemen, to answer the question now, you then have to come up with the most, the most cheapest replacement policy, as it relates to the equivalent annual cost, which means the lowest equivalent annual cost is going to be the best replacement policy. It's going to give us the idea. So that replacement cycle that has got the lowest EAC is going to be our replacement policy. It's going to be the best replacement cycle or replacement policy. So as you can see, if we replace this asset every 3 years, we are going to incur 38,152. If we are replacing it every 2 years, we're going to incur annually 44,878. Then if we are replacing over 1 year, we're going to incur 65,950. So you can see that to replace the assets every 3 years is cheaper. So therefore the asset should be replaced every 3 years. I hope you have enjoyed this video, ladies and gentlemen. Don't forget to subscribe to my channel, as well as to share the video, to like it, and to make some comments so that we improve in the way we offer our services. Until next time, ladies and gentlemen, may you continue to feel very blessed. I am signing out.